more than 100 miles below the Earth's surface, where pressures are 50 to 60,000 times greater than at sea level, it may only take a few days for a stray chunk of carbon to crystallize into diamond. It's the travel time that's a killer. As much as 3 billion years for that diamond to catch a ride on some volcanic magma up to the Earth's surface. 3 billion years. Diamonds may be forever, but no one wants to wait that long to get one. So at Genesis Diamond Labs, they're simply eliminating the travel time. They're making diamonds right here on the surface in 4 days. Not fake diamonds, but real diamonds, with the exact same physical, chemical, and optical properties as the mine variety. The process begins with a seed, a tiny diamond speck not much bigger than a grain of sand. It's this tiny seed around which a full-grown diamond will form, just like the pearl that starts with a grain of sand. Technicians begin the process by inserting the seed into a ceramic core along with pieces of graphite. Graphite that will eventually become the diamond. This hefty machine, called the growth chamber, holds 14 heavy metal pieces called dies. They form a globe around the diamond core. Now, to simulate conditions in the Earth's mantle 100 miles down. The chamber is hydraulically pressurized to 850,000 pounds per square inch. The temperature is raised to 2,700 degrees Fahrenheit, almost the melting point of steel. Powerful forces. But how exactly does this create a diamond? Like diamonds, graphite is a form of carbon, but its molecular structure is different. The loose bonds between graphite's carbon atoms are what make it soft enough for pencil lead, while its diamond cousin, with tighter molecular bonds, is the hardest substance in nature. The pressure and heat cause the graphite in the core to break down into carbon atoms, which are attracted down to the seed and bond to it, using the seed itself as a molecular template. Then they begin to align themselves in the rigid, evenly spaced structure of a diamond. The core remains under high heat and pressure for 4 days. And by the end of the process, a few chunks of graphite have transformed, as if by magic, into a diamond. Or so they hope. The core is delicately opened. Inside is what looks like a lump of carbon, but it's not. An acid bath burns away the excess graphite. A cleaning solution clears the rest of the debris. And finally, the birth of a new diamond. It took all of 4 days. Like most cultured diamonds, this one has a yellow tint because of trace amounts of nitrogen in the growth chamber. Of course, this man-made gem needs to be cut before it can dazzle. But how do you cut the hardest natural material in the world? Only one thing can do it: another diamond. The first cut is the deepest, but the trick is not to cut any more than you have to. The blocker covers the cast iron wheel with glycerin glue and sprinkles it with diamond dust. The dust is ground into the wheel, and the stone is locked into place on a vise. It takes the blocker nearly 2 weeks to cut a single diamond. There's a lot of money at stake in getting it right. But a diamond isn't a diamond if it doesn't sparkle. To make sure it does, the diamond is now handed over to the brilliantier, who cuts a number of smaller facets. Now this is a diamond. The popularity of cultured diamonds is growing every year. They cost 30% less than the mine variety. And now that diamonds can be made from organic carbon here on the surface, a whole new diamond industry is starting to spring up. There's even a company that'll make you a diamond from the cremated remains of a loved one. Which just goes to show that diamonds are forever. And you could be too.